This is Unit 13, Properties of Solutions, Video 13.6, Concentration of Solution. There are many terms that we use to describe a solution. A quantitative term would be concentration. That talks about the amount of solute dissolved in a specific amount of solvent. We can say a solution is saturated. That means the maximum amount of solute is dissolved in the solvent at a given temperature. We can also talk about solubility. The term solubility is quantitative because it, in fact, pinpoints the maximum amount of solute and solvent at a given temperature, and the unit that we use for that would be grams per liter. Solubility refers to grams per liter. If we're talking about the molar solubility, then the term would be moles per liter. And of course we can convert back and forth between those two just by using the molar mass. But keep in mind that both terms do refer to a saturated solution. With some compounds, it is possible to produce what's called a supersaturated solution. In other words, you would heat the solvent up, add the solute till it's saturated, and then slowly cool it down below that saturation temperature. And at that point, it would actually contain more solute than it should at a given temperature. It's very unstable. We say it's metastable, and just a little vibration can make it suddenly crystallize. This is something we'll actually do in the lab. I'll show you a supersaturated solution. Now let's move on to concentration. The most common way to describe concentration in the lab is to use the term molarity, and it's a capital M. Molarity is moles of solute over liters of solution. Now I want you to pay special attention to this term right here. It's not liters of solvent, it's liters of solution. In other words, the volume includes the solute and the solvent. Let's advance to number 7 and look at an example on how to mix a molar solution. The question says, a solution is prepared by mixing 25 grams of magnesium chloride in enough water to make a 450 milliliter solution. Notice the way that the problem is set up. They didn't say they added 450 milliliters. What they said was they added enough water to make a 450 milliliter solution. Now we're set up to solve a molarity problem. The first step is to change this mass into moles. So we'll take 25 grams and we'll divide it by the molar mass of magnesium chloride, which is 95.21 grams, and round it to 3 sig figs and get 0.263 moles. Now we are ready to complete step 2, which is the molarity. In step 2, you take the moles of magnesium chloride divided by the volume of the solution, rounded to 3 sig figs, we get 0.584 molar magnesium chloride. A three-sided equation like molarity is easy to solve with the decision triangle that looks like this: moles divided by liters, molarity. And we've seen this before, just a reminder. So if you're asked to find moles, it's going to be molarity times liters. If you're asked to find liters, it's moles divided by molarity. And if you're asked to find molarity, it's moles per liter. Just a little quick way to solve any type of molarity problem. Now here's another common problem that you'll see on the AP exam, and this will be talking about the ions themselves. Let's say that you're given a 1.25 molar solution of barium chloride. The question is, what's the concentration of chloride ions? The first step will be to write the dissociation equation, and in this case 1 mole of barium chloride will give you 1 mole of barium ions and 2 moles of chloride ions. So it's a 1 to 2 ratio. The next step will be to apply that ratio. If you did it factor label, this is the way I'd set it up. 1.25 molar barium chloride. For every 1 mole of barium chloride, you get 2 moles of chloride ions, and you can see that the barium chloride cancels and you double the 1.25. A typical problem that you'll see, and we'll practice some of that in class. And that brings us to the end of video 13.6, concentration of solution. Go to Moodle, look at questions and 13.6 and answer them at this time.